Okay, hello guys. So let's discuss some problems of Division 2 Codechef Status 91. Okay. So in this video, I'm going to discuss all these problems one by one from A to A, B, C, D, A to E. Okay. And you can also read if you want some short explanation for these problems, you can also read it on my blog here. I will give the link in the description. So you can find all the code and basic explanation of the video here. Okay, so let's start with the discussion. So Alice and Bob are playing a game, and in this game, in each turn, if the server and the other player is receiver, okay, one is server and one is the receiver, and if the server is the winner, then we increase his score by 1, otherwise it remains the same, and the other player becomes the server, and this goes on. So this is a very simple problem and it can be done by brute force. So just initialize a boolean to see if A is server or not, and keep a track of the scores and iterate in the string, and if that person is the server, then we increase the score by 1. Otherwise we just change the polarity, we just change the value of this boolean variable, and then we can again check if B was server, and that's all. So it is a very simple problem. I'm not going to discuss it any further. Let's move on to the next problem quickly. So odd GCD permutation. We are given an integer n and we want to print a permutation of n such that the greatest common divisor of all the numbers at odd indices is greater than the GCD of the numbers at even indices, and we want to print that permutation. Okay, so this is also a very simple problem. Let me just try to wait. So we have numbers from 1 to n, right? So 1 2 3 till n. Now at some, let's say for n equal to 5 or n equal to 4, if we have some even places and some odd places, and there are two observations. GCD of 1 and any number x will always be 1. So that means that if we have 1 at at even index, then the GCD of even place will always be 1. Okay, and GCD of and if we have 1 at odd place, then GCD of 1 will GCD of odd places will be 1. So, and in the question we were given that we need to make the GCD of odd places greater than GCD of even places. So that means that 1 must be at an even place. I mean 1 should be at even place, yes. And GCD so we can say that GCD of even will be equal to 1, and since the smallest even number is 2, then we can place all the even numbers at odd indexes, and hence the GCD of odd indices will be equal to 2, like that. And we also want to print the lexicologically greatest number, so we can say that okay, lexicologically greatest permutation. So for n equal to 6, we can first print 6 at since 6 is the largest even number, we can place it at the odd index, then we can place 5, then we can place 4, then 3, then 2, then 1. So what is happening here is basically, okay, I think I complicated it in my answer yesterday, but basically we are just printing it in the reverse order. This should also work. Let me just test it here. Or wait, let me just run it once. 6, okay. So basically we just want to print it in reverse order. Now if n is odd, this is a special case. For example, let's take n equal to 3. We have only 3 permutations, so either we have 1 2 3, or we have where we want to place all the odd numbers on the odd place, or we can place sorry, we have to we can place 2 1 3 because we want to place even numbers at the odd indices, right? Then it is not possible to cover all the even numbers in the odd indices if n is odd. You can try all the permutations, but it will never be possible. Let's also try for n equal to 5. If n is equal to 5, then we have 4, then some odd number, then 2, then some odd number, and then we also need one more even number, which is not possible in case of odd numbers. Hence, if n is odd, then we simply have to print -1. Okay, so that was the solution. And if n is odd, I am printing -1. Otherwise, I can simply print I actually did this by mistake. I mean, I didn't think like that. Okay, so we can simply print from 1 to n plus 1 and increase it by 1, and this should also work. Okay, you can also read the explanation given on my blog here. I will give the link in the description, so make sure you check it out. Let's move on to the next problem. Chef odd. So we want to partition a set S from 1 to n into k subsets such that the sum of elements is odd. Okay, and the number of elements in every set is greater than or equal to 2. This line is very important, that the number of elements in every subset should be greater than 2. Okay, let me clear this page first. Okay, so let's do this also by observation. So if n is odd, let's take for example, or let's just discuss the case for even numbers first. If n is even, so let's take n equal to 12. So 1 2 3 4 5 6 7 8 9 10 11 12. Okay, and if I ask you what is the maximum number of subsets in that you can make in this criteria, so the proper explanation will be, we know that odd plus even is odd, and odd plus odd is even, and even plus even is also even. So we have to print we have to pair all the even numbers with at least one odd number, right? So we can pair all the odd numbers with all even numbers with at least one odd number, right? So we can say, and the minimum number of element in every subset is 2. So we can pair these two numbers, we can pair these two numbers, we can pair these two numbers, and these two, and so on. So that the sum remains odd. This will give one odd number, this will give one odd number, this will also give one, this will also give one odd number, this will also give one odd number, this will also give one odd number. So the maximum number of subsets that we can make is 1 2 3 4 5 6, right? And from this we also know that the sum of these two odd numbers will be even, and sum of these will be odd. So we can replace every 3 odds by an odd number and another single odd number, right? So we can in place of these 3 we can place one odd number and let the others be there. So we can also have 4 subsets, we can have 6 subsets, we can have 4 subsets, then we can combine these and we will have 2 subsets, right? Let's also discuss the case for n equal to 10 quickly. So we have 1 2 3 4 5 6 7 8 9 and 10. Okay, then we are going to club these two 7 8 and 9 10. So we have 1 2 3 4 5, and so the maximum number of subsets that I can get is 5, right? And then we can club these 3 odds to get a single odd number. So 1 2 3, and this will give me 3 subsets are allowed, 5 subsets are allowed, and this will give me 1. So that means 1 is also allowed. Basically these are the values of k, right? These are the values of k that are allowed. So we can clearly see that k has to be less than or equal to n by 2, I mean the floor of n by 2, right? Okay, let's also discuss the case for odd numbers. Let me just clear the page first. Suppose n equal to, let's take a smaller case here, n equal to 7, 1 2 3 4 5 6 and 7. So we want to have so we can club these and these two together. We have, this will give us an odd, this will give us an odd sum, this will give us an odd sum, but we can't have this 7 roaming freely because this will be a set with an odd sum, but it will only have a single integer, right? So we actually have to club at least these together, right? So if this in case of odd, we can't take the maximum, that means if I take the seal of n by 2, right, then we can't have this value as k. K should be less than seal of n by 2 if n is odd, right? So that was the solution. Let's just see the code. Okay, so as I told you, this is my blog page, and you can even if you want to see the solution, you can come here and see and read the explanation given here, and this is my code. Okay, so first I'm taking the seal of n by 2. Okay, and if n is odd and k is x, then I'm printing no and continue. Okay, and k cannot be greater than x, k cannot be greater than seal by 2, then also we have no. Otherwise, if n is odd and k is also odd, then we get a yes, else we get a no, and else you get the idea, right? So basically we just want to check the polarity. Both are even, then yes. If or both are odd, then yes. Otherwise we have to say that otherwise it is not possible. Okay, so that was the solution for chef odd. Let's move on to the next problem, maximum permutation. Okay, so you are given an array of size n. The array will be used to perform q queries, and for each query you executed, you are allowed to rearrange the elements of a. Okay, so we are not given a, we need to find that permutation of a, and an integer x is initialized to 0, and for of the ith query you need to. Okay, so basically let's clear this page first. Okay, so suppose we are given, okay, so we are given several queries here. I think I should use a boxed, wait a second. In this question we are given L and R and some queries, right? So let's just see the first test case. We have 1 and 4 and 2 and 3. Okay, so we have two queries, 1 and 4 and 2 and 3. So if I have, suppose my array some in the permutation of a is something like 1 2 3 4 5, it was, yeah, n equal to 5 and q equal to 2. This was given for the first test case. So it is saying that the first query is from 1 to 4, 1 to 4, and the second query is 2 to 3. Okay, so we want to maximize the elements. Suppose here was a1, a2, a3, a4 and a5. So we can say that, okay, for when the first query is executed, my sum will become a1 plus a2 plus a3 plus a4, and after the second query it will become a2 plus a3. So overall the sum is a1 into 1 plus a2 into 2 plus a3 into 2 plus a4, like that. Or I can say that okay, so this is my final answer and I want to maximize this, right? Now how can we, now if we think about it, how we can maximize it. Suppose, okay, let's see how we can do it in brute force. One way is that whenever I am given this like for every query, for the first query, when I am given 1 to 4, I can make an empty array, right, and which is initially 0 0 0 0 0 for this, and for 1 to 4 I am going to add 1 1 1 1 like that here. Okay, and once I have and for 2 to 3, just forget about what's written here. Okay, and for 2 to 3 I can add 1 1 here. So my after all these queries, my final array will become 1 2 2 1 0, right, and I can check for I can sort this, and wherever I find 2, I can place my maximum number, that is 5. Then for the second 2 I can place 4 here, or I can even reverse this, it doesn't matter. Then 3, then 2, then 1, and like that I can obtain a permutation which will give me the maximum sum, right. Now I think this was the easy part. Most of us can think like that, but the tricky part is this is taking the time complexity of n into q. We want to reduce this to either we can actually reduce it to n plus q, and this will remove the TLE and will give us a correct solution. I actually tried all the segmentary and sparse table, but it does not work. We actually what we have to observe was like for 1 to 4, when we want to add, the array becomes 1 1 1 1 and 0, right. Now this is my index array that I want to okay, let me just name these to avoid the confusion. This is my index array, so I can say x. If I define another array, difference array, see this operation is taking O of q, O of the range is r minus l, right. So this is taking r minus l time to increase the sum. If I take the difference, so that means if I say the first element is 0, then 1 minus 0 is 1, this minus this is 0, this minus this is 0, this minus this is 0, and this minus this is let's say it is minus 1, right. Wait a second, minus 1. So basically in the in this original array I have to add it is taking r minus l, but if I want to make a difference array, it is taking O of 1 time to process, right. So and how can we obtain from d to x? I can just take the prefix sum, so 1, then 1, then 1, then 1, then 1, and it will become 0. You can and I can discard this and I will get the difference array, right. So basically we can define a difference array such that d of I is equal to x of I minus x of I minus 1, and after every query we can do d of l plus plus and d of l minus 1 and r minus minus, right. And after doing that we can take the prefix sum of this difference array, and that will produce the x, that is the index array. And from that, once we have received this once we have received this index array, then we can easily convert it by sorting it and recover the maximum permutation array. So it will so this is how we solve this problem. Now you can read the code on my blog here, and I've also provided the basic editorial here. So first we try to find a difference array, and every time for every L and R I'm doing L plus plus and R minus minus. Okay, and when I take the prefix sum, I will get the index array. Now I can sort and recover the permutation. Okay, so that was it. Let's move on to the next problem. XOR and Sum. Okay. I don't know why when I actually tried this problem, I don't know why the Python solution did not work, but let's see the approach here. And we can try solving this from subtask to subtask, like for 0 to 100. If I say, you can solve this by simple 2 for loops and try all the possibilities. If we have 0 to r raised to power 2k minus 1, or I will show you by doing this. I think that will be better, and that will lead to better understanding. Okay, so if we are given, let's say for this second test case, we are given r is equal to 2 raised to power k minus 1, also some power of k minus 1. That means r has all the set bits, right? Like 15 or 31, like that number. So let's take it as input, and okay, and what I can do is I can make 2 for loops. So let's just make an answer as a set. Okay, and I can do 2 for loops for I in range okay, I had to take L and R as input, right? Wait a second. Map and not split. Yeah. So L was 0 in this case. L is 0 and R is 15. So I can take 2 inputs, and when this since L is 0, so I can traverse from L to R plus 1, and for J in range I can still traverse from L to R plus 1. And if we are given that 2 numbers L and R, the count of each negative, and we have A XOR B is equal to A plus B. What this means, that suppose when if I see the binary representation, then A plus B is equal to A XOR B, and we know that 1 XOR 0 is equal to 1 and 0 XOR 1 equals to 1, and 1 or 0 equals 1 and 1 or and 0 or 1 equals to 1. This means, and this is also true, that 1 or 1 equal to 0, and if we add 1 or 1, this will give me 1 0, right? So basically it means that if this is true, then A and B equal to 0. That means that they have no common bits. So if my 1 is if my A is 0 1 1 0 1 1, then my B will be simply the reverse inverted form of this. So 1 0 0 1 0 0, like that. If my A is this, then my B is this, then this condition holds, and X is equal to A XOR B. So if I want to do that, I will calculate my X, that is A XOR B, I mean I XOR J. If I plus J equals X, then I'm going to add it to my answer variable, and then I can print the length of answer. So it gives us 16. Actually I should print the answer variable also. So we can see that it has all the numbers from 0 to 15, and even if I do 31, it will have all the numbers from 0 to 31. So for the second test case, that is 0 to 10 raised to power 2 raised to power k, the answer will be simply 2 raised to power k plus 1. That means you just need to check, that means the answer will be r plus 1, the length of this range plus 1, right? For this third subtask, if r is somewhere else, some 10 raised to power 18, you can actually also read it in my blog here. If the for the third test case, the r is 0, what you can do is check the maximum value power of 2 less than r, and the answer will be that r plus 1. And for this fourth test case, if this is 10 raised to power 5, so here the constraint allow for some n log n type solution, right? So what we can do is we can select X, let me say subtask 4, we can say select some x and see is or b, right? So we can select x and we suppose my x is 2 raised to power suppose my x has most significant bit as something like 1 0 1 1 0, like that. So basically we can write it as 2 raised to power k1 plus 2 raised to power k2 plus 2 raised to power k3 and so on till 2 raised to power k. If it is a 64 bit number, it will be 64, right? Or let's say that k1 was the maximum bit, then it will be some kn if it is an n bit number, right? So what we can do is we can give 2 raised to power k to the r and all these to l. Why? Because we want to okay, so why we are doing this? Because if we give more of these numbers to r, then my l will decrease and it might happen that x becomes less than l, right? So that was the catch here. We just need to traverse, and for every power of 2 that is present in this range, we can see if this maximum bit is less than r, and if the sum of these lower bits is greater than l, and if that is the case, then x will be my answer. So you can traverse like that. So now let's see the fifth test case, fifth subtask, that we have no further constraint. L can also be 10 raised to power 18 and r can also be 10 raised to power 18, and okay, and for this, let me just clear this page here. If both are 10 raised to power 18, what we can do, I will just open my blog here. Okay, so we know that L may or may not be 0, right? L equal to 0 or L not equal to 0. So for n equal to 2, let's start with a simple test case. We have let's say 0, we have numbers 0 1 2, right? What are my values of x that I can get? I can get zeros or 1, that is 1, ones or 2, that is 3, and I can also get zeros or ones or 2, which is also 3. So, or let me just, why am I doing it like that? Okay. So we are getting all the numbers from zeros or ones or twos or 3. I forgot I can take the 0 also, and for 2 we can take zeros or 2 like that, and twos or 2 and ones or we can also take zeros or 2 and we will get 2. So basically we are getting all the numbers from 0 to 3. If we have a 0, we will get all the numbers, because zeros or any number is simply that number, right? So if we have a 0, we are getting all the numbers. But suppose if we have 1 to 2, then we have pairs 1 comma 1, 2 comma 2 and 1 comma 2, right? And this is giving me a 0, this is giving me a 0, and this is giving me a 3. Let's see, if we have numbers 1 and 2, then we are only getting 3. Why is that? Because we can't take this, because if x is less than 1, right? So what we can do is we can select a number. Let's see. We can find all the power of 2's in the range of L and R, and for every power 2 we can say R minus L to the answer. So in this we have 2 in this range. Then in this test case, we were simply the answer was R plus 1. Just like that, our answer will be simply k plus 1, that is 2 plus 1 and like that. Okay, so I don't know why the Python solution did not work with me. We can simply iterate over L and R, and there is a special catch here, that if we have the first element as 0, we can't do 0 1 the answer will increase by 1, and like that. If we have power less than 2, because we want to, okay, now if we for the less powers we can give it to L, and for the more powers we can give it to R. And for that, if my 2 raised to power the least power is less than L, then we can't consider it, and it should be actually be 65, because we have maximum 64-bit numbers, right? And if we have more power of L, then it will exceed my maximum range, then I should break. Otherwise I am simply going to add this to my answer, 2 raised to power minus L. So here is the C++ code. I am taking L and R, and answer is 0. If L is 0, then answer will become 1. For I in range 0 to 66, because we have 64 bit numbers, you can take any value greater than 60, it doesn't matter. And what we can do is we can take 2 raised to power I, and if x is greater than I, suppose it becomes 64, then we don't have to x is greater than R, then because like I told, when we fix x, so it was 2 raised to power k1 maximum significant bit plus 2 raised to power k2. If this maximum is greater than R, then x will automatically not be in the range of A and B. Then suppose x is A's or B, right? Then x will automatically then B will automatically leave the range bit of L to R. So we can't have that. That is why I am breaking out of this loop when x is greater than R, and if x is less than L, then also we can't have it. So simple the answer will be 2 raised to power k minus L, and then we just have to print out the answer. Okay.